Very good morning, children. Even today we are going to start with solve some more problems regarding the force and laws of motion, and then we'll go to the next topic. From the next class, we'll be starting with the new lesson. Okay, today we are going to solve the problems regarding force and laws of motion. And notes will be uploaded, children. Some of the problems will be done in the notes also. So if you have any doubts regarding the notes, you can come and ask me. And you might have come to know that the corrections of the classwork will be done on Monday. So make sure that you complete your classworks on time and get it corrected on time. Okay. Now let us start with the problem. What are the two formulas you are going to remember by solving the force and laws of motion? That is the first one, Newton's, according to the Newton's second law. What is the formula you are going to remember? F is equal to mass into acceleration. Correct. What is the SI unit of force? The SI unit of force is Newton. What is the standard SI unit of mass? Standard SI unit will be kg or gram. And the acceleration will be given in meter per second square or kilometer per hour square. The standard units are these, children. You are going to remember this when they have given the question. The previous class we had solved, no, we have changed the given grams into kgs and we did like that only. You are going to convert the things and do the problem. Now, what is the next thing? The change in momentum. What is the change in momentum? That is change in, that is the sum of momentum initially, that is before collision, is equal to sum of momentum after the collision. That is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is before collision and this is after collision. Initial velocities will come before the collision. Final velocity will come after the collision. You need to remember these formulas. And today you will be learning about one more new formula, that is impulse. When the sum comes based on that, we'll solve based on that. Okay. Now let us go to the problem. I guess you can see the board properly. Two objects. These problems are not there in your classwork, children. So make sure that you copy these problems also in your classwork. Two objects of mass 100 grams and 200 grams are moving in the same line. So what they have told, they have given two objects. So two objects in the sense, which formula you should remember? First of all, when there is two objects, you are going to remember the change in momentum. That is the conservation of momentum formula. So the mass of first one is what? Solution. Mass of first object will be 100 grams. Mass of the second object will be 200 grams. Clear? Are moving in the same line and direction with the velocity. They are moving. That is the initial velocity. Your initial velocity will not be 0, children. They will mention, see, the velocities are 2 meter per second and 1 meter per second respectively. They collide and after collision. So here you need to remember the word after collision indicates that is the final velocity. From next whatever we read, that is the final velocity. Initially of this line whatever we read, that is the initial velocity. So what is this? U1 is how much they have given? 2 meter per second, and U2 is given as 1 meter per second. They collide and after collision the first object moves at a velocity of 1.67 meter per second. After collision, remember the derivation. After the collision, what was the velocity you named it? It is V1 and U1. Correct. Final velocity you named it, right? Like that only here. V1 is how much? V1 is 1.67 meter per second. Correct? And determine the velocity of the second object. They are asking after the collision, before the collision, the second object velocity is already given, that is 1 meter per second. They are asking after the collision, what is the velocity of the second object? So the velocity of the second object will be V2 is equal to question mark. Correct? Now you have M1, M2, U1, U2, V1, V2. What is the formula you should remember now? You should remember the conservation of momentum formula, that is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. You should say along me, then only you will come to know about the formula. Then what is M1? 100. Now, look at the both children here. Meter per second. See our SI unit side. Meter per second should be in kg. When they give kilometer per hour, it should be in grams. Now I have meter per second here, but it is kg. So I need to convert this grams into kg. So if I convert it into grams into kg, what happens? 1 kg is equal to 1000 grams. Correct? So let me do the conversion here. 1 kg is equal to how much grams? 1000 grams or 100 grams. How much grams? It is 1000 grams. Then 100 grams is equal to how much kg they are asking. What will you do? You are going to divide it. Correct or no? Let me take this as x. X into 1000 is equal to 1 into 100. Then x you should find out. Multiplied 1000. What happens if it is coming this side? It's get divided. Very good. So 1 into 100 is 100 divided by 1000. How many zeros? How many numbers you have here? 3 numbers. How many numbers you have here? 4 numbers. So more. Denominator is more with 1 number. So what are you going to do? Before this number, you are going to put a 0. That is 0.1 kg will be the conversion for 100 grams. How much kg is it? 0.1 kg. Now, for 100, it is 0.1. For 200, it is how much? 0.02? No, it is 0.2 kg. Very good, you are. So, it is 0.2 kg. Then my meters is all same. So, meter per second, meter per second, meter per second. All my velocities are same. Only thing was the mass was different. So, we converted into kg. Everything else is fine. Let us start now. Now, in place of this mass 1, what should I write? 0.1. And U1 is how much? 2. Plus, what is M2? M2 is 0.2. Into U2 is what? 1 is equal to, again, M1. M1 is what? 0.1. V1 is how much? 1.67. Plus, M2 is how much, children? It is 0.2. And V2 is how much? V2 is that only we should find. Great. It should be found out. Now, let me multiply inside bracket. I should remove, no? 2 ones are 2. And 2 zeros are 0. So, it will be 0.2 plus 1 into 0.2 will be 1 into any number is same number. 2 into 1 is what? 2 itself or 3? It is 2 itself. Then it is 1 into 0.2 will be 0.2 itself. Then let me calculate this. Where shall I write? I'll write here itself. 0.1 into 1.67. 7 ones are 7. 7 zeros are 0. Plus 6 ones are 6. 6 zeros are 0. Plus. 1 ones are 1. 1 zeros are 0. So how much you get? 7, 6, 1, 0. See children here, after decimal point you have 1 number. After the decimal point you have 2 numbers. So 1 plus 2 will be 3 numbers. After how many decimal points? After how many numbers you are going to put the decimal point? You are going to start counting from your left hand. See here 1, 2, 3. So after 3 numbers you are going to put 1 number and 2 numbers. 1 plus 2 is 3. So after 3 numbers you are going to put the decimal point. So you will be having 0.167 plus 0.2 into V is 0.2V. V2. Clear? Now add. 2 plus 2 is 4. 0 plus 0 is 0. So it is 0.4. And this plus, if it is coming this side, what happens? Minus 0.167 is equal to, what is left out here? 0.2 V2. Understood? Now subtract it. Now subtraction 0.4. Then 0. So it is 167. I do not have numbers here. So put zeros. What you are going to do? Subtraction. Then this will be 3. This will be 10. And this becomes 9. And this becomes 10. So 10 minus 7 is 3 itself. Then 9 minus 6 is how much? 9 minus 6 is how much, children? 3. Then 3 minus 1 is 2.0. So you will be left with 0.233 is equal to 0.2 V2. Correct? No? Check whether it is correct or not. It is correct. Now, the next one. The next step. 0.233 divided by division. See here 0.2 into V2 it is. Into if it is coming this side, it gets divided. So it is 0.2. Now yesterday, the previous class I have taught you, correct, how to change the decimal place. Now it has been coming. If it is 1 decimal place, here also change it for 1 decimal place. Here the second decimal place, I do not have any number here. So what do? I'll put a 0. Next, the another 1 decimal place, another 1 0. So you will be having what? 233 divided by 200. Did you understand? So it is 233 divided by 200. Yes or no? Yeah. Now let us divide it. Let me make it proper. So it will be 0.233 divided by 0.2. Okay, after 1 decimal point I shifted here because both denominator and numerator has decimals. So let me put another 1 decimal point here. Now here it is not there. Let me put zeros. So it will be 1 decimal point. Let me go with 1 decimal point. Another one, another one. So you'll be having 233 divided by 200 is equal to V2. Clear? Now divide it. 200, how much are 233? 200 ones are. 33 is not here first. 200 ones are. It is done. Ones are. Now 33 is left. 233 minus 200, you will be left with 33. Now if I put point, you will get 330. Let me do the division here. I think you are getting confused. So let me do the division here. 200, 233. Ones are 200. Subtract. So it is 3, 3. This 2 minus 2 is 0. Put a point. If you put a point, what you will get? 0 you will get. Now start multiplying. Again, 200 into 2. 2, 0, 0, 2 2s are 4. You will get 400. 400 will go? No. So again, ones are. 200 ones are. Again it is 200 itself. So you will get how much, children? 0 minus 0 is 0. 3 minus 0 is 3. 3 minus 2 is 1. So you got 130. 200 where? 130 is where? There is no combination only. Then here already 0 point has been put. You can take 1 0 whenever you require. If this also doesn't go, then you are going to put 0 and then you are going to take another 1 0. Okay. Now you have 1300. 1300. When you will get 1300? 2 5s are 10. Correct? 2 5s are 10. 10 with this. See here. 200 into 5. 0 0. 2 5s are 10. You got 1000 for 5. Let me do it for 6. 0 0. 2 6 are 12. If I do it for 7, it will be 1400. It is more. So 6 are 1200. Again, you will be left with 1 0. See here, again 0. It becomes 1000. 200, how much are 1000? 200. 5 it is 1000. So you got the answer as 1.165. What is V2? V2 is equal to 1.165. What is the SI unit? See the velocity SI unit? Meter per second. Correct? Did you understand how to find out the velocity? So you are going to say, after the collision, the velocity of the second object will be 1.162 meter per second. Clear? Any doubts? Yeah, let us go to the next problem. I'll erase these formulas, children. What is the next one? Second one of this class. An object of mass. Along with me, you write the question or pause it and then write the question. However, it is possible. Make sure you understand the problem first of all. An object of mass 1 kg acquires a speed of 10 meter per second when pushed forward. What is the impulse given to the object? Now, what is this impulse? It is just change in momentum. What is momentum? Momentum is equal to P will be equal to mass into velocity. That's all. See, they have given you the velocity, they have given you the mass of an object. Randomly, you are going to say impulse is equal to change in momentum, where change in momentum is given as mass into velocity. I will be equal to mass into velocity. Simple it is. Now, solution. What is the solution? And let me write mass. What is the mass given here? 1 kg. Then, what is the speed of an object when it is pushed? That the speed v is equal to 10 meter per second. Then, impulse will be equal to change in momentum. So, what is change in momentum? Change in momentum, that is P will be equal to, let me write here, that is P. Momentum is equal to mass into velocity. Directly let me write mass into velocity. I will be equal to mass into velocity. Okay. Mass is how much? 1. Velocity is how much? 10. 1 into 10 is what? 10. Mass is kg. Velocity is meter per second. So you will have 10 kg meter per second as the impulse. See how it is easy? It is very much easier. Then the next problem, I guess this might be the last second problem or the last problem. Using the what? Momentum formula, change in momentum formula you will be using to solve the problem. The next problem is the third problem. From a rifle of mass 4 kg, a bullet of mass 50 grams is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity. That is when you trigger the rifle, before triggering. Velocity of the rifle. Recoil in the sense it is before triggering. Now, let me start. From a rifle of mass. What is the mass of the rifle they have given? So, let me start with the solution. Mass of the rifle, Mr. I'll write mass of the rifle as Mr. Mr is how much given? 4 kg. Now, a bullet of mass 50 grams is fired. So what is the mass of the bullet? MB. MB is how much? 50 grams. Now I need to convert this gram into kg. Here 100 grams 0.1 kg. 50 grams will be 0.05 kg. Understood, children? If one zero is reduced here, you're going to add one more zero. If it is 5 grams, it is 0.005. Okay, if it is 1000, then it will be 5 kg. How much zero you will increase here? That much zero will be reduced here. How much zero you will decrease here? That much zero will be increased here. Clear? Yeah. So the bullet mass will be 0.05 kg. Then the initial velocity of 35 meter per second fired with an initial, which is fired, bullet is fired with the initial velocity. So initial velocity, that is UV is given. UV is how much? 35 meter per second. Calculate the initial recoil velocity of the rifle. When you trigger, before triggering, what is the velocity of the rifle? That is UR, they are asking you to find out. What is conservation of momentum? Formula? Conservation of momentum is equal to initial, that is before collision is equal to after collision. But before collisions are equal each other, right? When we were supposed to derive the formula, we took initial velocity will be equal to initial velocity, that is FA will be equal to FB. Do you remember? The force of first object will be equal to the force of second object. That only here you will be applying according to conservation of momentum. What is the two object you have? That is momentum of rifle will be equal to momentum of bullet. Understood? How did you get? So momentum, two objects are equal in momentum. So momentum of the rifle will be equal to momentum of the bullet. So what is the momentum? Mass into velocity. Velocity, what velocity you have here? Initial velocity. You are talking about rifle. So rifle mass, rifle initial velocity. Understood? So what does momentum? P is equal to mv. That is mass into velocity. What velocity is given here? Initial velocity of what? Bullet. So it is v. So mass of the rifle is how much? 4. Initial velocity you should find out is equal to mass of the bullet is how much? 0.05 into initial velocity of the bullet is 35. Then now the 4 is multiplied here. If you take this 4 this side, what happens? It gets divided. So UR will be equal to 0.05 into 35 divided by 4. Correct? Now UR will be equal to multiply now. 5 5s are 25, 2 carry, 5 zeros are 0, 0 plus 2 is 2, 5 zeros are 0, plus 3 5s are 15, 1 carry, 3 zeros are 0, 0 plus 1 will be 1, 3 zeros are 0. So you will be having 5 plus 2 is 7, 1, 0. After how many decimal? After how many decimal points? Sorry, after how many numbers do you have decimal point? After 2 numbers you have decimal point. So you need to keep after 2 numbers a decimal point. So it will be 1.75 divided by 4. Stand with 2 on the children. If you do not know 4 ones, it's okay. Not an issue. You have 2 ones. Now start with 2 ones. 2 ones are 2. 1 will not go into. So you put a 0. After 1 you have point. Put point. So this 1 comes here now. It becomes 17. 2 how much are 17? 2 8s are 16. Then here 1. So it is 15 now. So 2, how much are 15? 2 7s are 14. 1 more is there. You already put a point. So for 1 you will be having 0. So 10 it becomes 2 5s are 10. Clear? Understood? Do you want me to repeat it again? See, 2 1s are 2 2s are 4 it is. then you have 1. 1 won't go in 2. So I put 0. If I put a point, this 1 will come to 7, towards the 7. So 1, 7 is there. 1, 7 will be 17. To how much is 17? 17 will not go. So 2 8s are 16. 16 you will be 17 minus 16 will be 1. So 1 will come to this 15. 5. So 1 and 5 will become 15. So 2 how much is 15? 15 won't go. 2 7s are 14. One more 1 will be there. You have already put the decimal point. So it is 1 and 0. 1 and 0 will be 10. So 2 how much are 10? 2 5s are 10. Now again 2 1s are 2. 0 will not go. 2 zeros are 0. It's a point. 2 how much are 8? 2 4s are 8. Here no remainder. Next number 7. 2 how much are 7? 7 will not go. But 2 3s are 6 will go. 7 minus 6 is 1. Again you will get 15. 2 how much are 15? 2 7s are 14. 1 will be there. You have already put a point. So it will be 0. 2 5s are 10. So what is the initial velocity of the rifle? The initial velocity of the rifle will be 0.4375. What is the SI unit you are going to write? Meter per second. Understood? So what are you going to conclude your answer as? The initial velocity or the initial recoil velocity of the rifle UR is equal to 0.4375 meter per second. Clear? Understood? So shall we do one more problem based on the impulse? Anyhow, the question is ready. So we'll change the question and we'll do one more on the last problem. So let me change the mass. Let the mass be 5 kg and this be 50 meter per second. What happens at that time? Read the question. An object of mass 5 kg acquires a speed of 50 meter per second when pushed forward. When it is going to push backward, you are going to get negative sign because the impulse is acting on the backward side. We'll do backward. We'll change it. Front goes back. One problem backward, one problem centward. It will be easy. So backward. Backward in the sense it is going back. When you push back, what happens? The object goes back only. So it is negative. See, I am standing here. If someone push me back, I am going back. Correct. It is a negative. I will fall. If they push front, anyhow I can balance, I can keep. But if they push me back, I cannot keep anything. I will fall off. So it is negative. What is the impulse given to an object? So V will be mass. My body weight will be same only. If they push me front or if they push me back, it will be same. But my velocity or I'll be resting like this. I'll be like this. If they come and push me, I'll go and fall. So it will be negative. U will comes negative. Mass is 5 kg and my velocity is 50. So it is minus 50. Impulse is change in momentum. What is momentum? Momentum is mass into velocity. So my momentum will be 5 into this velocity will be minus 50. If it is minus 50, plus into minus is minus. Correct? 5 5s are 25. 5 zeros are 0. So what is the answer you will get? You will get the answer as minus 250 kg meter per second. So the impulse will be minus 250 kg meter per second. Understood? When it is backward, it will be negative sign. If it is forward, it will be in positive sign. So here sign conversion has happened, children. Plus into pluses, plus itself. Plus into minus is minus. Minus into plus will be again minus. Minus into minus will be plus. See, same sign plus. Same sign plus. Different sign minus. Different numbers like that only, you will do subtraction also. If one is positive and negative, another one is negative, then only you will do subtraction. See, when will you do subtraction? Minus 7 plus 5. How much is it? See, different signs. One is minus, one is plus. Minus 7 plus 5 is how much? 2 you will write. Then what will you do? See the greater number. Which is the greater number? 7 is the greater number. 7 has negative, so it is -2. If I change, now you will write again 2, 7 minus 5 only you will do. No, why? There plus signs are there. So 7 plus 5 will be how much? It will be 12. Correct? And this will be negative. If this is negative, negative, what will you do? Same sign, again positive. Positive you will do and put the greater number sign. Clear? Understood? So the sign conversions are very important by solving the problems in physics and the SI units. Clear, children? This ends this topic, that is the force and laws of motion. From tomorrow, that is the next class, we are going to start with the new lessons. Some more problems are being given in your notes. The PDF will be sent through the website. So make sure that you will learn the questions, whatever it is given, solve the problem, solve it. If you have any doubts when you are going to get your class for correction, at that time you can come and clear all your doubts. Okay, children? Thank you. Save and read for the things. Thank you, children.